Welcome everybody to today's FDTD GOES Applications webinar. Today we're pleased to have Doug Wesley from the AWU in Anchorage joining us, and the title of his presentation is New Applications of GOES15 Imagery in Volcanic Plume Detection for the VAAC and Alaska region. Next slide. Just a few things to go over before we begin. All of these are recorded and available on the visit web pages at the following URL. Also, call for speakers. If you're interested in leading in one of these in the future, just let either myself, Dan Bicus, or Scott Lindstrom know, and we can get you scheduled to be leading one of these. Next slide. And just some protocol, Doug will have approximately 20 minutes for a presentation. You can either send questions via the GoToChat, or we'll have a Q&A period over the phone after Doug is done with his presentation. We'll be done by 18:30 at UTC. And remember, do not press hold, and also remember to mute when you're not speaking. At this point, I'll turn it over to Doug.
Okay, can you hear me out there?
Yeah.
Okay, hello from snowy Anchorage. I'm going to talk about some new applications of GOES15 imagery just over the past few months that we're currently using for volcano plume detection and prediction from the VAAC here, from the Volcanic Center here in Anchorage. So can you see that first slide with the volcano name on it, Dan?
Yeah.
Okay, so we're good to go. Okay, on March 15th of this year, in the morning hours, from the Himawari satellite, situated way out west over the Pacific, and west of there, we noted a strong plume of volcanic ash coming out of the VAAC eruption, and we were notified very quickly by Tokyo, and the Tokyo VAAC quickly issued an eruption VAAC and a volcanic ash advisory shortly thereafter. And you can see that. Can you see my cursor, Dan? Are you okay with that?
Yeah.
Okay. So, a couple of things to note here. This is the Kamchatka Peninsula here. There it is. Okay. And I apologize for not marking these a little better, but the Alaska outline of the AWU FIR is shown here, and the Aleutians are down in this region. So we're talking way west here, where the volcano erupted. Also notice that the initial few frames of this eruption, the signature was relatively circular. In other words, this was a strong and deep eruption, unlike what we've seen over the past couple of years, and it was deep. It was well deep into the troposphere, up to the tropopause, likely, and the Tokyo VAAC stated that they could detect it to 50,000 feet. So this is a major eruption of the VAAC volcano. And I've got this loop going until 2150Z on the 15th, and this is just the initial portion. So at this point, at the end of the loop, the Anchorage VAAC does not have any responsibility except to issue a near VAA or a near volcanic advisory, which just advises our airspace that there is an upstream volcano, and the ash will likely invade our airspace within 6 hours. So a little background on VAAC. It has a summit near 10,000 feet, and the eruptions in modern history started in about 1955. The last major eruption, I believe, was December of 2017. And there have been 3 periods of intensive activity in the past 3,000 years. So there's a picture of the volcano itself. That's from from the web source shown, and it's just a historical picture of the mountain itself. So the location is in the east central portion of the Kamchatka Peninsula. And I went back and with Dan Self, I got a GFS analysis at 06Z on the 16th. It was a few hours after. This is the time period that our VAAC starts to get interested in, and we look at the steering level winds. It goes up to 50,000 feet, so I chose, just for display purposes, a 300 millibar wind speed and heights at 6Z on the 16th. And this is about 30,000 feet up. And we see that the winds were in the order of 40 to 50 knots in the region. And 6 hours later, we see the same. They've strengthened a little bit, maybe 55 knots in this region. So that's what we're going to be dealing with the eviction of the Plume. We looked at the Shimya sounding, and that's located, the nearest sounding location is Shimya Air Force Base, and it is in this location. Yeah, this location right here. And so it's a little bit south of the area of interest, but it's the closest sounding. And we see the tropopause at about 270 millibars, and winds are 45 knots at that layer. They don't get much stronger above that. In fact, they weaken to 35. But generally, we're talking about 40 to 50 knots up in this area. So let's get to some GOES15 imagery, and this goes from 04 to 23Z on the 16th. So this is a few hours after the last imagery that I showed you. Let me back up to the Himawari. I forgot to mention the mainland Alaska, the west coast, is in this area. So it's well east. It's in a couple thousand miles east of the eruption at this point. But I want to mention that you can tell that the satellite imagery from Himawari is fairly poorly resolved. We're out in the limb area of the satellite, so the data is getting degraded by distance from the satellite at this point. So let's go back and go to the first photo out. So this is showing several of the new satellite data sources that we have here with a new position of GOES15. And in the upper left, it's the ASH RGB. And RGB, just a little background, and I don't want to get into too much of the detail because the intent is not to provide training on RGBs here. That will be referenced later. The intent is to just show you some recently collected data which has a lot of potential for improving our detection of these plumes. But the RGBs essentially play games with the colors on the imagery, and these are spectral games. In other words, they take the difference, take a couple of differences in the spectral imagery to isolate the effects of SO2 and ash in the imagery. In the upper left is the sRGB, and let me start animating this. And you can see the evolution of the plume as it goes right on through 12Z on Saturday the 16th. So at this point, let me back up a little bit here. So this is the ash signature, this orange color and the yellow color. And it vects well into the Bering Sea and well towards the Alaska, the Aleutian, the central Aleutians at this point. And it becomes very faint by about 18Z on the 16th. You can still see it in here, at least this portion of it, and that does some interesting brightening of the signature by 2030Z, and then it disappears by about 0Z in the 17th. By this time, it's entering the Bristol Bay region, which is this area. So up here on the SO2 RGB, that's shown up here, and let's look at that animation. And we'll talk a little bit about some of the applications of these colors in a later slide. But we want to track this plume as it goes right on into the central Aleutians by 15Z on the 16th. And then you can actually see the SO2 signature a little bit better at 21Z than you can on the ash at this time. And that goes on till disappears at about 0Z on the 17th. This lower left is the split window difference, or the difference in IR temperatures from two channels, and this isolates the plume just in the spectral difference in these channels. You can see that that's visible until about 14 or 15 Z on the 16th, and then it disappears. And then this lower right is simply the standard IR channel, 10.35 microns, and you can see the plume. Get my cursor back. It's in this region, and then it becomes masked by background cloudiness, but you can see it. Let's see. There's a point where you can see it across that clear area. Right there it is. So it's right across here. That's the last I see of it on the standard IR channel at 10.35 microns. So let's run through that one more time, and we'll get to the next data that I have to show you. So again, it goes on through the 16th of March, and you can see there's elongation of the plume. There's different levels being shown here. Excuse me. This is a relatively large signature of a plume. It extends for probably 800 miles across the Bering, and it remains visible until about 0Z on 17. Okay, now I'm going to show you some GOES15, but let me preface this. We weren't able to save the data in hindsight from AWIPS directly, and I got this from Dan at a later time and from the SIMS group or the SIRA group. And this will give you an example of what we had up until last fall to look at this imagery. And again, the projection is not as good, and unfortunately I don't have the AWIPS imagery, so just keep that in mind when you look at this. But you can see the plume enter the western portion out on the limb of the GOES15. Then it disappears. This is the standard IR channel, and you can see it. You remember when I crossed the clear area on an earlier slide from the GOES? There's the plume right in there, and you match up the times. You can find it pretty readily up until only about 10Z, and the rest of the time it is masked by this other clouds in here. So there are two issues here. The GOES15 is not in the position to give us good imagery, and it doesn't have the advanced baseline imagery data that we need to assess the plumes from a satellite perspective. Okay. So I want to reference some compute from the Commerce Learning Center website. There are quick guides on the ASH RGB, the split window difference channel, which I showed you, and the SO2 RGB. These incorporate differences. The RGBs incorporate differences in 2 of 3 components. The ASH RGB yellow color indicates ash and potential SO2. The orange and red indicate mostly ash. And we noticed that remember that we had yellow and orange on the ASH RGB in the previous imagery from GOES17. The split window difference color table is reversed so that the blue color indicates the likely ash. The SO2 RGB, orange indicates likely SO2 and potentially ash. A dark blue color in the SO2 RGB is potential ash and/or deep ice cloud. There is a low viewing angle effects on these RGBs, which we're doing a lot of. We're awaiting research on this from the satellite experts on the exact nature and the quantification of this low viewing angle. But we know there is an effect on the RGBs that needs to be considered when you look at the imagery on the edge of the satellite viewing region, and that's ongoing work. So let's look at some additional GOES15 imagery. Let's see here. Okay. So this is, again, Dan provided me with these loops, and this is the same similar imagery that you saw before with the ash RGB in the upper left, SO2 RGB in the upper right, the split window difference on the lower left. You can see it goes the plume nicely on through out 12Z on the 16th, right there, and go to the next loop. I believe this shows the same imagery. Now that's okay. Bear with me a little bit here. Okay, that's the view a little bit to the west of where we saw it earlier. So this is the edge of the GOES15 viewing area out here. The edge of Himawari is about in this location. We see the plume on the GOES15 from a different perspective to the west that's visible all the way up till about 12 on the 16th. If I move that over, you can see the plume on the SO2 RGB up until about 12Z. Okay, and I have one more. I think we change the color tables for this imagery. So on the lower left, the other two you've already seen. On the lower left is a little bit different color table that's implemented, and it really brings out the signature ash in the split window difference channel, as shown here. Just for interest, on the right is that's just the standard IR again. And you can see the plume as it crosses this area with ocean background in here. And you can make it out at about 8 to 10Z also in this area. Okay, what did this do for our volcanic advisories? Our area of responsibility is shown by the gray line here, and we came up with 60 knots in operations, and this is what, in collaboration with the Tokyo VAAC, we came up with 60 knots and from the surface to 50,000 feet for this major eruption. On the FIR boundary, the first VA needs to agree with Tokyo VAAC's issuance. So that's, and we saw earlier that the different levels of the ash gave it a strange shape with this sort of V notch in the back end of it, and that's what was handed to us by Tokyo, and we went with that. This goes out to 18 hours, out till 0340 on the 17th. You can see it progressing rapidly across the bearing and into the Aleutians by this time. So, the second one was issued at 13Z, and it's very similar in shape. It's just a little bit further east it has moved, and it is showing 40 knots at this point. I should mention we did, in hindsight, we did an estimate based on the Plume signature on satellite. We got about 70 knots in propagation to the east by the Plume. So slowing down a bit here, I'll show you in a bit. This is shown in the synoptic setting, the weakening of the winds as the Plume progressed eastward. This is at 13Z on the 13th, and you can see it's getting into, it's probably to get into, well into Bristol Bay region by 7Z on the 17th. And then at 18Z on the 16th, we issued another, and that's shown here. And what is usually used for this, with the state-of-the-art in our system, is the PUF model. There are new tools available on the web. The high split model is one. The ASH 3D is another model that's being used, and they're working on getting those in AWIPS. To make them truly operational, we need to get those in the AWIPS. But for now, we use, when we have time, we'll use the web-based guidance. Otherwise, we use PUF guidance. And that essentially is what is used for these later hours at 12 and 18 hours. Okay. So the analyzed winds by 0Z on the 17th. Remember, we had 40 to 60 knots out in here earlier on the 16th. It has slowed down to 30 to maybe 30 to 45 knots over the area of interest. And then this is shown in the cold base sounding here. We're getting that down to the 20 to 40 knot range. And let's see. And you can see that it actually is analyzed by O1Z is moving only 10 knots to the east. This is an operational volcanic advisory again, and it goes on through 13Z on the 17th. The VA was weakening this time. It's still observable in the imagery. And then the final VA was issued at 6Z on the 17th with a very weak signature. If you remember, we saw that on the previous loop at 6Z, and it was just about dissipated by this time in the GOES15 imagery, and we went out 6 hours with the VA, and then it was canceled. Some caveats about the SO2 RGB data. This is new data for the VAAC and the Anchorage VAAC. More research and case studies are required for operational implications. The nature of the underlying surface, this has been shown in the past with other case studies with GOES16. The background, land, sea, or cloud, can be critical as to what color you see on the SO2 image for the plume, and must be considered when interpreting the colors on the RGB. This is ongoing research, and this also includes the low angle viewing effects. And I might add, as an additional caveat, polar orbit data is very highly resolved data spatially, but is not addressed in this initial presentation, and that's beyond the scope. But it is useful at times for looking at these plumes in a very high resolution, spatial resolution, and the use of advanced imagers with that. Okay, the impacts of the volcanic ash itself. Now, unfortunately, we don't get rerouting information frequently with these volcanoes. There's a lot of air traffic in the 35 to 40,000 foot levels over the Bering, and there is right across the central Bering. There's a major transcontinental route for these aircraft. We presume there was extensive rerouting over the Bering Sea. We did not get any PIREPs. This is not atypical for this area. Over the Bering, whether that was because they weren't flying and they were rerouted, or they weren't reporting it, is a question that we can't answer. We did get some negative pyreps from the eastern Aleutians into the Sand Point, south of Anchorage, Cold Bay, Kenai, and Cold Bay again early on the 17th. And all of these reported negative on ash or negative on the smell, and that would indicate no SO2. But these pyreps were all in the Bristol Bay region, so they were in the dwindling stages of the plume. So, okay, I want to throw up a different case study now. Which looks like we have some time. This will just give you an idea of some other applications for different volcanoes. This is a Beni Amanoff, which is in this region, and this is the ash RGB. This is the SO2 RGB for an eruption. A shallow eruption occurred back in November when the satellite was in test phase. This is just a visible image up here, and this is the water vapor imagery here. So you can see it on the water vapor image, just a very faint sense here, but it does stand out. Now, the interesting thing about this is in rapid scan mode. I guess I don't know what the new term is for it, but it is a mesoscale sector, and so this is 1 minute imagery. So you can imagine this was not even detectable with GOES15, and here we are in November showing a shallow eruption of the Beni Amanoff. I think this was a 25 to 30,000 foot top eruption, but you can clearly see the plume on the SO2 on the two RGB images here. And let's see, I think I have this one. The Sierra folks, let's see. No, the CSU folks gave me this imagery of a volcano west of South America that erupted, and the ash RGB. This is Sierra Negra volcano back in 2018. So this is GOES15 imagery, I believe, and the ash RGB shows it quickly. This is a major eruption, but it shows it quickly dissipating. And when you go to the SO2 RGB, you see it retains the white color on out, and it also shows shallower SO2 in a sheared region at lower levels, but the deepest plume with the largest signature is retained all the way out, well away from the volcano, and that's just another example. Back to the PowerPoint. I can find my place here. Let's do that. Yeah, so this is dominated in the RGB by a white color, and this is likely high SO2, and it can generally distinguish between levels of the SO2 signature. The ash presence quickly decreased after the eruption. This is another example. So to summarize, I think my time is about up. GOES15 data represents a major improvement in volcanic plume detection in the eastern Bering, eastern Aleutians of Alaska, specifically for temporal and spatial resolution, and in the ABI imager with the derived application. This is in the RGB imagery and the split window difference that I showed you. It is likely that future assessment of Cook Inlet plumes will have unprecedented satellite data in high res. We have the mesoscale sectors set up now to where when and if and when a Cook Inlet volcano like Redoubt or Spur erupts, we will go into high res 1 minute imagery for that plume, and you can imagine the resolution that we will have at that point, and that will be a dramatic impact on our operation. I'll also mention the GOES15 hardware issues with the heat pipe issues, and the data loss because of this will eventually be an issue for Alaska. It's just a matter of that coinciding with an eruption. We've had a pretty quiet year and a half, and But we've had, 2 years ago in the spring, we had 2-3 volcanoes every day. So it just depends on when, but this data loss will eventually be an issue for Alaska. And with the potential loss of GOES15 at some point, that will be an issue too. So, and at the bottom are my acknowledgments. That's about it.
Okay, questions or comments for Doug?
Yeah, hey Doug, it's Brian Mata. How are you?
Good.
Hey,
Hi, Brian.
the VAAC, the VAAC products, are those basically constructed using the satellite imagery and trying to draw a polygon, similar to something like what you would use for a severe thunderstorm?
Yeah, I mean, this I've shown here. Can you see the slide I've put on here?
Yes.
That covers maybe on the order of 500 miles from this side to this side. So these are huge polygons compared to the severe weather. But yeah, we have a GFE equivalent currently, and we draw polygons, and you use the distance tool, and you have the imagery on AWIPS, and you can get used to it and fairly quickly draw these polygons. But notice that not only do you have to draw the polygon, you have to assign the speed and the height. So those are the challenges. And when a volcano erupts, we issue an eruption VA, and then we quickly follow it up with a forecast. The collaboration with the neighboring VAAC is critical there, but it's pretty hectic up front. It's easy to get yourself behind if you're not experienced. The longer lasting eruptions, the urgentness or the complexity, you've spun up on it, so you've had a chance to think about what you're going to do when you issue another VA in 4 or 6 hours. So it varies, but yeah, we draw polygons essentially on a GFE equivalent up here. Yeah.
So your main data sources are the geostationary satellite, the polar satellites, and the PUF model. Is that right?
Yeah, currently, yeah, we can, again, when the plumes extend for a long period of time, we have a chance to go on the web and look at high split or maybe ASH 3D. But yeah, within the system, the PUF model is what we're using along with the satellite data, essentially. And, any PIREPs that are reported. And there's also webcam data that for the illusions we can use to estimate or check on our plume heights.
Okay. So it would seem to me that if you had the GOES winds, the derived motion wind vectors,
yep,
that the ones that are trackable within the plume itself would help a great deal in terms of estimating the speed and level and that sort of thing.
Yeah, I know that's been mentioned here. I haven't messed around with it myself. I should probably know more, but I don't at this time. But yeah, I would think that would be worth looking into. You could probably get a representative value, and it would be easy to check on the values also using the distance tool on AWIPS.
Right, I guess the other issue with that is the anomaly. If it were during a time when the anomaly was having a strong impact on the IR, then that would affect those products and algorithms. Yeah.
One issue that, you saw this plume go up past the tropopause, apparently, and that makes the assessment of the plume top difficult because you have an isothermal, even more stable than isothermal, actually warming layer with height at that point, and so the old issue of getting the temperature from the cloud top, it gets complicated. That, Tokyo went with 50,000 on this. We had some some data, some satellite data suggesting that part of the plume was much lower, and it was uncertain, really, in the end, whether it actually got to 50,000. We're pretty confident it got to 40, but we're not confident it got to 50, and that's with the higher temperatures, with the tropopause, it gets complicated there.
Yeah. And one last question, Doug. Is there any thought in the future of going toward a more probabilistic type of polygon where you have maybe like a core high probability and then lesser depending on how the plume appears in the imagery or in the modeling?
Yeah, there is a confidence factor in these VAs. Let me find one for you. It's optional for the forecaster to, but usually in the remarks they talk about uncertainty. Yeah, I know Mike Pavlonis' group at Wisconsin has played around with some, and I think
in the lower right there, Doug, it says considerable uncertainty exists.
Right.
So I can see where that factors in.
Yeah, I think along with some computer help, I think this a certainty would be worthwhile looking into in terms of a VA, and I know our customers would like that also. I think that's in the future, and it's an area of ongoing work here. So.
Yeah, I remember with the Iceland volcano that the HER folks had a version of the model that they used to demonstrate, tracking volcanic ash. Do you guys have any kind of version of the HER that would do that up there?
Last time I talked to the Boulder guys, Trevor Alcott was leading that. I saw a demo of it in November. It looked encouraging. It was test mode. In other words, they just threw some ash in and watched it evolve and had a nice animation. My understanding was that was going to become operational early in 2020, I think. That's the last I heard. I haven't heard any updates on that. So.
Okay, cool. Thanks.
Yep.
Any other questions?
This is Bernie. Hi, Doug. Thanks for the presentation. And
Hi.
I heard you talking with Brian about some of the other GOES products, and you did mention Mike Pavlonis's, and so I thought I'd just revisit that. And I know that or at least I understand that the current volcanic ash product in AWIPS has not been updated to the latest and the greatest, and so I guess my question is, does the VAAC look at the Volcat page?
We do. Now, currently, we have a monitor that's beside the operational desk in there, and that is logged into an email, and Mike's is it Volcat? I think it sends us an alert, and that's automated. And it is very useful because some of those do hit initially on volcanoes, and they're very quick. And I will say that historically, I think 80 to 85% of those are false alarms because of the weather cloud and the uncertainty. But I think he's tracking global volcanoes with that. But you'll know fairly quickly when you look at it if it's something of concern, and it has. On occasion, it has contributed to an earlier detection of a volcanic event, of an eruption in our area. We need to, having that on Windows while you're looking at AWIPS, it kind of adds a step, and it's not ideal. But I would say that that the alert feature that Mike provides is currently important operationally in our VAAC here. So.
Okay, great, thanks. So, do you know, did this one have an advisory? It seems like because the plume went up quickly, it probably would have alerted them. Do you know?
It did. I don't know the details, but it did alert fairly quickly, and I think that was the initial. I'll have to do some checking, but I think that was the initial clue that that something had happened. If you remember that loop, I'll go up and pick it out again. The initial portion just looked like a bomb going off.
Yeah, it looked like a convective cloud. Sort of, yeah.
Yeah, yeah. On the initial portion is documented by the MOR, of course. It was circular right at this point, and then it quickly. These are strong winds aloft, 60 to 70 knots. But if you look again at the initial plume, it's circular, and that indicates a lot of updraft to me. Is what that tells me. And yeah, if I remember correctly, it alerted on the mic system fairly quickly. So.
Okay, great. And thanks again.
Okay.
Okay, any final questions for Doug? Okay, if not, then we want to thank Doug, and everybody have a good day. This concludes the webinar.